Hello and welcome to another episode of Projectpro Expert Talks. And today we have with us Sai Vinil Tamishetty, who is a senior data engineer at Walmart. Welcome to the podcast, Sai.
Hi, Devi.
Hi. And thank you for joining us, Sai. Okay, so let's start by, having your brief introduction. So, Sai, can you share a bit about your background and what has led to your current position in the podcast with our viewers today?
Sure. I currently work as a senior data engineer in Walmart in Bangalore. It's been 7 years. I've started working into this software industry. I started my career in Wipro, where I was working as an ETL developer, where I was mostly into the support related project, where I haven't looked at end-to-end projects of the data engineering. Use it to debug the issues on a day-to-day basis. And then I moved to a company called Edgeware. It is an product-based subsidiary of Infosys, where I was working more in the finance domain and working on an end-to-end product of the data engineering. And then moved to Altimetric. There we were working mostly on the exploration and analysis of the tools which can fit for the right use case. It's kind of an horizontal across the company, where we find the right tools, evaluate the tools, and recommend the tools based on the recommendations for the projects. In Walmart, I work in there are multiple projects I worked on in Walmart, which are mostly into the data platform, as well as then a full-fledged product into the uh, I mean, is more into the analysis of the e-com analysis and assortment analysis.
Okay, awesome, awesome. So, Sai, can you just give our viewers a brief overview of what your role as a data engineer looks like at Walmart?
Sure. It's similar to how a typical data engineer works. Mostly, it's related to the development of the data pipelines. But one of the critical thing what we face here is the volume of the data. Uh, as you are aware, Walmart generates the most of the it's generates the scales data at a petabyte scale and on a everyday basis. Okay, processing that data is a huge challenge at a Walmart scale. So we develop the data pipelines, and most of the we also need to follow the best practices while developing the pipeline, because it's not a few pipelines, we have thousands of pipelines in system. So maintaining when it comes to the pipelines at a scale, we face a lot of challenges. We might be facing the issues with the data quality and the maintenance. Development of a pipeline is easy, but once it goes to the maintenance phase, right, operations, it will be very harder if we don't follow the standards of the pipeline. Whether it's coming to the backfilling of the data, suppose you need to reload the data from the earlier things, and suppose a deployment of your pipelines, all this comes into picture. The multiple other challenges we face, we need to address them from the initial stage, from the development of the pipeline itself.
Okay, okay. So, Sai, considering your role is very challenging on a day-to-day basis, so are there any specific, major data engineering projects that you might have worked on during your entire career in data engineering? Could you just share any insights on those projects with our viewers?
Sure. I could say about one of the project which worked in early in my when I started in Walmart. It is related to the assortment. Suppose when you go to a retail store, whether it's suppose in India you can go to either DMart or any other retail store, you see the products placed in the racks, right? Every product placed beside is actually, there's a lot of analysis done when choosing the product, what to be placed beside the other product. Suppose if we want to change a product from one rack to the other rack, there is a lot of analysis and processing happens in the background, which actually take the spending behavior and customer behavior into the account. Actually, suppose if you see at the sales counter, you see candies placed at the sales counter, right? It's actually one of the they take in the consideration, children who go into the lines, they actually pick up the candies, and actually increases the sales of that particular product, right? And if there is an interesting use case a decade ago, where uh, placing the beer and diapers beside in a store actually increase the sales in US. There's a lot of analysis. Suppose there are a lot of reasons for that, why it has increased the sales, but choosing the right product in the right track in the right place is actually driven by the data analysis. This is a project, and this was interesting product. I mean, how to see, we try to find the customer behavior, how they are actually choosing the product after the choosing the other product.
I think it sounds very interesting. And okay, so while working on, this project and any other similar project that you have worked on, were there any specific challenges that you can, recall that you faced while working on them? And how did you exactly overcome those challenges?
Uh, from the data engineering perspective, I could say there are two kind of challenges. One which the data engineering faces, and one is something which organization faces. Okay, when we develop the pipelines, right? We develop the pipelines assuming the data at that point of time, but the pipelines might not be scalable in future. So all the pipelines which we need to design to take care of the data into picture, the amount of the data, it be whether our pipelines will be scalable, or what will the amount of data we can expect in future. All these design considerations should be taken at first. So it's not like the major challenge in the data engineering is scalability. The data is growing like very fast. So we need to take into the right trade-off while designing the data pipelines. Basically we need to understand the business use case. This is something which misses. I mean, initially when we are developing the pipeline, we might use normal practices and we develop it. But that will be a major problem in latter. And one more challenge I see is the schema evolution. The source system and the data engineering teams, the communication is minimal. What I faced is we need to be in contact touch. Continuous touch with the teams which actually produces the data, so that we can get the right changes. What are the changes happening in the source system? Suppose we while developing the pipeline, there might be only few columns or few, and the schema might be different, and later the schema might evolve based on the business use case which is producing the data, right? We need to adapt to those changes. As the change is happening in the source. Otherwise, the data what your pipelines is producing is actually going obsolete. It's not actually not making any sense. It's actually deviating the business, because whatever the data we produce is actually helping the business to take the decisions. And if we make the produce the data in at the in different wrong way, actually it impacts the business as well. It has a big impact on the business. And one
Oh,
more thing is
yeah.
challenges which organization faces is uh, data replication. Suppose I've developed a pipeline in my team, and there is other team which is they are also developing the similar kind of pipeline. They are also producing the similar kind of data. It's happening in silos. So all the data teams in an organization should be actually brought into a single horizontal. Then it can actually solve most of the engineering challenges from the data perspective.
Okay, okay. So that sounds like too many challenges at one side. Okay, so when it comes to like real-time data processing, how do you approach real-time data processing challenges?
Okay, real time. I think I worked on a couple of pipelines, but not much into data. Real time data pipelines. But one of the challenges when I worked, I realized is the latency of the data. When we say real time data pipelines, uh, once the data is produced, within how many seconds or milliseconds you are able to produce the final data set is actually matters. Suppose if you see now, after these IoT came into picture, the data is getting produced as a very high scale, right? uh, And once the data is produced from the in sensors and you produce at the end, and how much time it is taking is actually matters for the real time data pipelines. All the data systems should be in sync. Suppose if a sensor senses signal which has produced yesterday and other sensors are producing the data which are immediately, then it actually, you need to maintain that in the pipeline should handle those kind of scenarios. And maintaining data in sync is most challenging in the real time data pipelines. And also the latency of the pipelines, as well as cost. We also need to think about the cost when designing these pipelines, because the systems run every day, right? It's done 24 by 7, and we need to make a better trade-off while designing these systems, real-time systems. One more challenge is backup strategy. Suppose when we have two kind of pipelines in the data engine. One is a real-time pipelines and one is a batch pipeline which runs on after a certain time of interval. Suppose if a batch pipeline goes off, we'll have some time to recover that. But real-time pipelines should be recoverable immediately. It should have a proper backup strategy when we are designing the real-time pipelines. I mean, this is of much importance, because if a real-time pipeline goes down and if your data is accumulated for a few hours and sometimes few days, this will be really challenging to bring back the data. Sometimes you lose the data as well. If your sensor is sending the data, if you are not able to receive that, you lose the data, right? You will have proper system which can actually take care of that.
Absolutely, Sai. I completely agree with you on this one. Also, Sai, any specific strategy that you have taken up, while integrating data from, various sources for any project?
Hmm. This is I mean, this is a major challenge in data engineering. Like, you have n number of sources. You have something coming from the software as a service applications, and you get something from different applications, some data warehousing team. And suppose if you see from the business context, you get from different business teams the data, and all doesn't produce the data in a similar way. Some produce in an XML format, some produce in the JSON format, some produce in an normal they send the zip files for you, and this all data you need to bring into this common structure at the end, and then start processing on the data. This is something which need to be taken care. This is called as a data ingestion, and we need to build a generic kind of component which actually based on the source system, it should be able to convert into the right final destination system. And building that component depends on the actually the teams and the projects they are working in. This is something, if we are not able to design this proper data ingestion system, it actually faces, I mean, we need to face a lot of challenges in the while getting the data into our system itself. And if you don't get the data into your system itself in the right way, it we cannot process it further, right? So building this is more critical in any project actually.
I think this is going to be, very helpful for anybody who is, willing to join the data engineering domain, enter the field, or, is trying to understand exactly how to approach these challenges on a day-to-day basis. Okay, so Sai, I mean, as a data engineer, I'm sure you have worked with a lot of, data engineering tools for all your projects. So what factors exactly do you consider when you are, picking up any data engineering tools for a project?
Data engineering tools for a project, right? uh, One thing, while there are multiple tools in the data engineering space, I could say there are a lot of open source tools and there are a lot of enterprise tools available in the market. It depends on the requirement of the project. I mean, based on that we need to there is nothing like it's a right tool or it's a wrong tool. Everything has a specific use case. We need to actually find the right right requirement for the project, because most of the data engineering pipelines, how it works is, suppose if it's they're starting initially for the, suppose if a business requires some analysis, they start initially with just processing with a Python, and they bring the data and they show it to the reports. But that is the initial phase, and slowly the requirements keep on growing. And if we have a good long term view of the business, it will be helpful for the, I mean, understanding the right business strategy helps us in figuring out the tools. Suppose you are using, initially you might be using normal Python script to process and load the data. It becomes obsolete when the data grows, right? Sometimes they have a same use case. I mean, they don't want the data pipe, I mean, they are sure that data pipeline doesn't grow. At the time, it's okay to use Python. So understanding the right business requirements, one is the major thing. And then I could say limitations. I mean, if you say distributed processing, there are multiple tools which offer the distributed processing, but we need to check about the trade-off as well. I mean, what is the cost? Cost actually comes in the major picture. Initially might be okay, but once your pipelines grows and it starts into the production, right, you might realize that it's very I mean, it's not a cost-effective solution. I need to again revert the strategy with other tools. And the cost also we need to take into consideration along with the choosing the, I mean, along with the use case of that particular tool while finding the tools. I mean, there are a lot of things which take into account while designing it based on the requirements at that time. These are two something which are generic for applicable for all the applications.
Okay, so Sai, any specific tools that have helped you personally in any of the projects or that you like using more than, the rest of them?
Okay, specific tools. Most of the time I spent in data engineering using Spark. Okay, initial days I was spending using. I mean, 7 years back when I started, it's only the MapReduce and Hive and big data. I mean, these Hadoop clusters what we have in the market. But when cloud came into picture, right, it has segregated the entire storage and the computing power of the our systems. So it has brought a major breakthrough in the, I mean, I could say in the data engineering domain. You can store your data separately and you can spend for the computing power only whatever you require. But earlier it was not like that. Earlier I was using most of the time as a Hadoop, writing MapReduce programs. But after this Spark and other tools came into picture, right, I mean, it changed the way we program in the big data processing thing. So I spend most of the time in writing Spark programs and optimizing them, optimizing those Spark programs. And it's uh, because Spark has a huge ecosystem and it's an open source and it has a huge community. Now it has integration with more all of the tools. It has an integration with the ML. And I don't say it's only one tool which provides all the solutions, but a lot of other tools. But I could say this is something which solves most of the use cases. Yeah, this is something where I spend a lot of time there.
Great, great. Also, Sai, reflecting on your, entire experience from your career, what are the, some of the valuable lessons that you have learned from, overcoming all these challenges that you have mentioned? And how would you like to advise your fellow data engineers or, viewers who are watching this podcast today? And now, what advice would you like to give them for, overcoming such similar challenges for successful project outcomes?
Okay, one thing I could say is being strong on the basics, on the foundation, whether it's a data engineering or any other tech stack. Being strong on the foundation, even if you work on any complex project, all they actually build on the basics itself. Okay, being strong in the foundation is the most crucial point. I mean, thing, whether it's any domain. So I could say, I mean, spend more time on basics instead of going around these fancy tools or fancy technologies. If you're good at that, it actually helps in taking the right design decisions. And being upgrading in the industry is much important actually. Suppose no one gets a chance to work in all the projects, that's for sure, but there's a chance we can learn from other projects even though haven't worked there. So there are a lot of, I mean, a lot of companies actually are maintaining these engineering blogs, which they provide actual solutions they have worked upon. Instead of just demonstrating the idea or concepts, they actually provide the solutions or they tell about them what they worked in the real world, right? I mean, this helps in taking the right decisions and design considerations in when we work in other projects. So this helps a lot. I mean, speak with the community and learning from the community helps a lot. And one of the major challenge in data engineering who come in the industry face is uh, it's not like they can develop a project on their own in their system, because the problem is we cannot create clusters and these are chargeable, and these we need to pay for that because uh, it requires a lot of computing power and a lot of data as well. So these kind of real world experience we get only in the project. So I always advise people try to get in the projects which are available in the company. I mean, when there are people who want to uh, learn, they cannot learn from their own. I mean, they can learn from their own. Implementing will be challenging for the data engineers. So work in the projects, I could say, instead of just learning there.
I
And
think that's, yeah, yeah, please go ahead.
one more thing is developing the pipelines is easier sometimes, but focusing on the optimization is also important. Suppose there might be pipelines which are running for 6 hours or 8 hours or per 12 hours, but those can be optimized. Most of them can be optimized. We only always think about delivering the work at that point of time, but if we see in the long term, I mean, optimizing the pipeline in the initial level might be challenging for any team. They need to first actually work on a solution. When the solution is ready, we should not ignore that. We need to spend again time on optimizing that. Suppose if you see in the software thing, there you will be easily engineering. Suppose if you think about software engineering, they develop these websites or they will develop their backend technology. They can immediately see the results of that, whether how much time it is taking. But here in the data engineering, one of the challenge is we need to have a lot of patience here. The pipeline you run here, it might take 6 hours. Again, you need to optimize it, and it might take 5 hours. You need to reiterate on that. You might not see the solution immediately. So we need to be a lot of patient in the data engineering field, I could say. uh, we need to optimize the pipelines, and definitely we can bring the 6 hours or 10 hours running pipelines into as less as possible, most of the cases.
I think that are some really good and valuable pieces of advice for our viewers, Sai. So thank you so much. And that brings us to the end of this podcast, Sai. Thank you so much for taking out time and joining us for the podcast today.
No problem. Thank you, David.
Have an amazing day, Sai.